So this is where I think like visually this might make a little more sense. And I'm going to kind of draw this out because I think we have enough time to kind of draw this out. And this is, for the record, the video from 3 Blue 1 Brown is really good. I think highly suggest going. It's only like 10 minutes long. I think it does a good job like showing this demonstration. And it's not this exact scenario, but it's very similar. So you can kind of think of like this is the full population. Okay, and this is a square, by the way. So we have the square of a population, right? And you can think of it like a sliver of this guy, and I'm going to put it like in green, of being like, okay, all of these guys, this is the sick population. So obviously I didn't write it to scale. This is like one person, right? Or like one column. And this is like 10,000, or like, I guess technically 9,999, right? So like 1 out of 10,000 people, right? I think that's how I wrote it down. So you can imagine this part. And you can kind of think like, okay, there's a very small sliver that is actually like really sick, right? And then of this part, and I'll write this, we'll say green is sick. Well, I'll just leave the other one blank. And then let's say I'm trying to, my tools, like my colors are not in the way. Okay, I'll use dark green. So I think that'll stand out well enough. And so if these people are sick, we want to know who's positive, right? Like who will test positive, because that's what we care about. That's what we tested positive. We want to know, all right, who are we more likely to be a part of? So I can look at this like, okay, like, well, if we're sick, right? Pretend these are like, let's say this is like, this is a graph of like 10 or a square of like 10,000 by 10,000 people, right? Does that make sense? Like 10,000 people here, 10,000 people here. So a total of, oh my gosh, I can't do math today. Sorry, what's 10,000 times 10,000? I have to think it like in this terms. I have to go 10 to the power of 4. It's 10 to the power of 8. So that's like 10 million? No, 100 million.
6 zeros in there, 6 zeros.
6 zeros?
Yeah, 6 zeros.
1, 2, 3. I saw a calculator. It's 100 million, right? Yeah, okay. 10 to the power of 8. Sorry, I have to think exponents. I can't think in like the comma stuff. So, okay, so we have 10 million people. And so we have like all of these people, right, are sick, right? We'll say, what does it matter? Like, say this is all these people. And if they are sick and they take this test, 99% of them, we'll just make a like graphical part, 99% of them are going to test positive. Does that make sense? Right, because the test is 99% accurate. Now we have the rest of these guys right here, right? And this is where it's kind of like, you have to kind of imagine, because I'm not going to do it to scale, but we have all of these people here. They're healthy. If they all took the test, only 1% of them is going to test positive, right? So you can kind of think of that as like, again, this is not to scale, right? So like, imagine this thing is really small. So I'm going to just draw it a little bit to scale, is that this is probably closer to like this amount, right? Because like, this is not like 1%. This should be like a very small sliver of everyone, right? So like maybe you'd have something like closer to this part where this is 1% of the population. Okay, and I know I didn't like exactly do the numbers, but this would be approximately what you would look at, right? So then you really ask yourself, well, what are you more likely to be in? Are you more likely to be a part of this group or in this group? And if you do the numbers, right, if you actually do this actually graphically, like, and you make sure you do like 1,000th of a slice, right, you would see that this value is very, very small compared to this value. In fact, there's almost 100 times more people in here than there are over here, which is why we get about 1% chance of us actually having the disease. Okay, does that make sense to people? Cool. All right, so this is what 3 Blue 1 Brown kind of shows. Another way of showing this is a little bit of like saying, if I seen this more like in a tree. So I'm just going to quickly show it to you guys. I'm not going to go through the full details because I think you guys can probably, I think this actually does a better job of explaining it than like my tree part. But you can kind of think like, okay, event A, right, is that the probability of us being sick. Well, there's 9,900. Let's pretend there's 10,000 people, or yeah, 10,000 people. There's 9,999 people who are, or actually I'm going to go add some zeros. There's 10 million people. Okay, so we have 9,000 or 9,999,000, right? And then 1% of those people are going to be sick. or 0.01%, right? So that would be how many are sick versus how many are healthy, okay? And then we split it again for testing positive, right? So that's event B. Well, of these healthy people, right, 99% of them, I'm not gonna, if someone wants to do the numbers, you can, but 1% of these people are going to test positive, which is what we care about. Okay, so 1% of these people, which is, do the decimal, so it's 9900 of them. No, I have a 9. I have 9s missing, sorry. 99990. So that's like 99,000 people are going to test positive. And then in this case, for the people who are sick, 99% of them are going to be testing positive because they are, actually have the disease. So 99% of this is 990, right? I think that's the right math. Even if it's wrong, it's close enough, right? Don't make me do math in my head in front of people, right? So you can see real quickly is that, oh yeah, this is definitely a lot smaller than this one. And in fact, if I divide this out, if someone wants to do this really quickly on their calculator, I saw Jessica had a calculator. If you want to do this really quickly, if I did this right, this should be about 0.98. It should be actually exactly if I did it right, but we'll see. Okay, so I did some numbers wrong here, but it is it should be 0.0098, right? So Jessica showed it was 0.009. I think you had it, Jessica, right? So yeah, this should actually be, because it's not 98%, it's, yeah, perfect. All right, I did some numbers wrong in there, but that's okay. I did it close enough. It's because I didn't, oh, you know what, because I didn't do the whole like percent probably correctly. But you can see that that's kind of the idea there, is that you can see there's a lot more likely that you're positive and part of this group than over this group. And that's really what Bayes' theorem is saying. And that's where Bayes is like, this is so obvious. And the rest of us are like, yeah, Bayes, sure. And that's why we use numbers, to make it a little bit easier. Okay, cool. Does anyone have questions about like overall what this looks like, how this kind of works? Thumbs up if you're feeling pretty good. Thumbs down, you're like, I don't know what's going on. Sideways, you're like, okay. All right, cool. I think see most people getting thumbs up. Like you had 2 fingers up, so that's good.